James Webb Telescope just got an extra dose of life, set to exceed 10-year lifetime in space. Analysis reveals that the telescope used less propellant than what had been originally planned, for the mid-course burns to put it on the right path to its destined orbit. Designed for an operational life of 10 years, the James Webb Space Telescope could work way beyond this time frame. The new development comes after the analysis of the telescope's initial trajectory to the second Lagrange point nearly 1,500,000 kilometers away from Earth. Webb's team analyzed the fuel and the engines, after the 2 out of 3 mid-course correction burns, and said that the observatory should have enough propellant to allow support of science operations in orbit for significantly more than a 10-year science lifetime. The analysis reveals that the telescope used less propellant than what had been originally planned for the mid-course burns to put it on the right path to its destined orbit. Please let us know what you think of our videos. Also, if you have not subscribed to our channel, Secrets of Space, please subscribe to get notified about new videos in future. The spacecraft has rocket propellant in its tanks, not only for mid-course correction and insertion into orbit around L2, but also for necessary functions during the life of the mission, including station-keeping maneuver small thruster burns, to adjust Webb's orbit, as well as what's known as momentum management, which maintains Webb's orientation in space. Additional fuel will be used for what NASA calls station-keeping maneuvers, small thruster blasts to adjust Webb's orbit, once it reaches its destination on the far side of Earth, in an area known as the second Lagrange point, or L2. It's a million-mile journey and is expected to take about 6 months. Webb will have much more than the baseline estimates of propellant, though many factors could ultimately affect Webb's duration of operations. Crediting the precise launch by the Ariane 5 rocket that took it outside Earth and put it on a trajectory away from the planet, NASA said that extra propellant is largely due to the precision of the Ariane 5 launch, which exceeded the requirements needed to put Webb on the right path. That added boost, and also allowed the JWST solar array to unfold about a minute and a half after it separated from the Ariane 5, just 29 minutes after launch. The array was coded to automatically deploy, either when the observatory reached a certain altitude, or 33 minutes after launch, whichever came first. Once there, it will begin sending back to Earth unfiltered images of the farthest and oldest reaches of the galaxy, about 13.7 billion light-years away. That's 13.7 billion years back in history, only 100 million years after the Big Bang. It's a quantum leap forward from the Hubble telescope, which launched in 1990 along with the Discovery space shuttle. We would like to show you specifications of the James Webb Space Telescope, the world's largest and most awaited space telescope. Primary mirror, 21.3 feet, 6.5 meters, across, with 18 gold-plated hexagonal segments that collect infrared light, which is called as a light bucket. Sunshield, a 5-layer metal umbrella, the size of a tennis court, to protect the probe from the heat of the sun, the Earth and the Moon. Near-infrared camera, Webb's primary imager, will detect the earliest stars and galaxies that formed. Near-infrared spectrograph, this tool can use infrared information to inform scientists on physical properties, such as the chemical composition and temperature of galactic bodies. Mid-infrared instrument, this has both camera and spectrograph that can detect objects in the mid-infrared electromagnetic region. Near-infrared imager and slitless spectrograph, this one's thought to be particularly useful in exoplanet detection. Fine guidance sensor, used for navigation. Please let us know in comments below, what do you think about James Webb Space Telescope? Thank you for watching.